Rabi, hello Rabi,
Sir. Yes, sir.
how are you?
I'm fine, sir. How are you, sir?
Alhamdulillah, we are also fine. Look, here we discussed till here in last class. Thermal energy equals mass times specific latent heat. Okay, and here one thing left, that is evaporation. Evaporation we'll discuss later. Today we will go through this one again little bit. We have one numerical on this formula. Then we'll go to this distinguishing properties of solids, liquids, and gases, their molecular structures, and how the molecules are moving with the temperature, and pressure, how pressure is involved with the motion of the molecules. So all these things we will try to cover today. And if we get time, then we'll continue with evaporation also. Okay, let's start. Here we have the specific heat capacity. The previous one we did completely. Are you getting me? Hello, everyone.
Yes, sir. Yes.
And the recording is going on, right? Can you check
Yes.
the
Yes,
recording
sir.
is going on? Yeah.
Yes, sir. It is.
Thank you. So here you see we discussed all these things: melting, boiling, boiling point, melting point, condensation. This graph also we discussed. They who missed the class, you please check the recording. It will help you a lot.
Sir, Farabi is in the waiting room.
Farabi is waiting. Okay, I'm checking. No, no one is in waiting room. Okay, tell him to change the name. Maybe his sister's name is Fabiha. That's why I was asking that who is that Fabiha. That's why I did not accept. Can you please tell him in the group that you come with your own name, not Fabiha? Yeah. Qazi Jawad, you tell him.
Yes, sir.
Yeah. Tell him to join with his own name, not Fabiha's name. Fabia is his sister.
No, sir, he is not online.
Okay, okay. Fine. You see here, latent heat of fusion and latent heat of vaporization we told also previously. Here you see these things we discussed, right? Latent heat of vaporization, latent heat of fusion. So during melting we are getting latent heat of fusion, and during evaporation, during boiling we are getting latent heat of vaporization. Okay, Rabi, can you remember that one we discussed? Hello, you were reading this one. You are saying L1, but it is LF. Okay. Hello, Rabi.
Okay.
Yeah. So look here.
Yes, sir.
We are getting here.
Uh,
Here, this equation. This equation we can write as specific latent heat one. We can write as LF equals LF by M. Okay.
Sir, L টা কি? Latent heat আর F টা sir?
This one, this suffix is showing you, is it latent heat of fusion or latent heat of vaporization?
Oh,
When we have melting, then we have fusion. latent
Oh, melting
solution.
fluid.
Yeah, we have latent heat both for melting and boiling, right?
Yeah, yes, sir. Then
Yeah,
boiling would
so
be
yeah,
like
during
what, sir?
boiling it will be latent heat of vaporization. That time we are using this
Oh,
LV.
evaporation.
LV, small LV equals
Sir, the formula will be same or a bit change? Will it change?
LV divided by M. Everything is same, only we are writing the symbol in different ways so that we can separate them, right? Is it
Yes,
clear?
sir.
And
Yes, sir. Clear.
specific latent heat and latent heat, the difference is when we are saying latent heat is for the whole object, and when we are saying specific latent heat, then it's for only 1 kg object. Is it clear?
Specific latent heat for 1 kg object. And sir, another one what you told?
Yeah,
Only latent heat.
it's for the whole
Yeah,
object.
yeah. Sir,
Like if the object is 5 kg or 10 kg or 15 kg, 20 kg, then for the whole object we are getting latent heat.
oh, latent heat. Okay, sir.
Yeah, and
And
for one,
specific.
yeah, for 1 kg object we are getting specific latent heat.
Oh, okay, sir. Okay.
That means when we are getting latent heat, we are having only LF equals Q. You see, LF equals Q. Q means the energy supplied or energy required to melt. Okay, from solid to liquid. To turn solid to liquid, we need some heat, right? Hello.
Yes, sir.
So that heat is actually directly giving you the latent heat. So this equation we can also write this way. LF we can replace with Q. In our specific heat capacity, you got this Q, right? Q is the energy supplied, the thermal energy supplied, right? Can you remember that one?
No, sir.
Yeah, in specific heat capacity and heat capacity, you got this Q, right? C,
Yes,
C
sir.
equals C equals you got here Q equals MC del theta. This way you got the formula. Can you remember that one?
No, sir.
Yeah, you can check the recordings, previous recording. Also in your book is available. Okay, we did that one, and also we did numerical questions. You sometimes you go back, huh? Then you can get it. Look, here we have in back these things we discussed before. Look, before melting boiling, we did heat capacity, specific heat capacity. This question also we did, right? Here is the formula. See, C equals uh, small c is Q by M del theta. So we can write Q equals MC del theta, right? This one we did. Can you remember now? We discussed all this. His specific heat capacity, then the heat capacity.
Yes, sir.
Now it's coming in your mind. Look, which one is heat capacity? That is C equals Q by del theta, right?
Yes, sir. Remembered. Yes, sir.
Yeah, we did this, and also we did this numerical questions. We did specific heat capacity, small c equals C by M, then Q by M del theta. Right, all these things are available. Yeah, then you can rearrange the formula. Q equals MC del theta. Right, now you can recall. Hello.
Yes, sir. Yes.
Okay, so please have a look. Again, you go through. In your book, it's available. In your class recording, it's available. Go through the Google Classroom. Everything is orderly arranged over there. They who missed the class or they who forgot, you please check out. Otherwise, you cannot link, because we have linking with one another. One concept will be helping you to go forward with other concept. Okay, so last class we did latent heat and specific latent heat. This question, you see, we were discussing. So we will go with this one now. Can anyone please read this one? Here, an ice cream.
An ice cream has a mass of 150 gram. If the specific latent heat of fusion of ice is 340,000 joules kg or 340 kilojoules kg, find the heat required to melt the ice cream. So that is -1
Which one?
kg upper
Okay,
one.
this one. This one. Look.
It's joules per kg.
Yeah, joules per kg is coming like that. If you are taking this way, joules per kg, then we can also write as this way, or we can write this way. Sorry, or joule per kg. Okay, 1 by kg we can write as kg inverse, right? Is it clear now?
Yes, sir.
Yes, sir.
Okay. So sometimes we will get this one also, joule per kg. This way we will write. Now this one, Shafkat, you read. Shafkat, please
Okay.
read again.
Solution.
Yeah,
Given
solution.
mass is equal to 150 gram, which is if we convert, then it will come 0.150 kg. Specific latent heat. So what is that?
It is LF, small LF. Okay, small L, then F.
Yes.
You just say LF, a specific
LF is,
latent heat LF. Yeah.
okay, sir. LF is equal to 34 lakh joules per kg. Using LF is equal to, sir, I cannot see. LF is equal to,
Yeah,
so,
LF is capital LF equals small LF multiplied by
okay,
M.
okay, small LF multiplied by M is equal to 34 lakh into 0.150 is equal to 51,000 joules, and if we convert, then it will come 51 kilojoules.
Okay, so this formula, look, the formula I wrote here, that one we can rearrange, right? This formula we can rearrange. Are
Yeah.
you clear? Are you clear about this?
Yes, sir.
And after
Yes, sir.
rearranging, we are getting this formula. This one, why I am writing in this way, so that you can understand easily that it is specific latent heat. If you
Sir,
divide
what is the latent heat given here?
latent heat, they told us to find. Look, I told you
Okay.
one thing. I told you one thing, that heat required to melt the ice or to melt anything, that is called latent heat. That's why I wrote here LF equals Q. So find the heat required to melt the ice cream. That means they are asking you the latent heat. Is it clear now? Hello?
Yes, sir.
And for your more understanding, or to get it easily, as the question is asking you the heat required, we can write this equation instead of LF equals MLF. We can write also this way Q. That is more, you can recognize it this one more easily, right? Q equals MLF. If you write this way, as they are asking heat required, so that it can be easily picked by you. You can write this formula. Okay, Q equals MLF. So it's coming with heat required. Q and LF, the capital LF is same thing. Is it clear? Hello,
Yes, sir.
everyone. So just remember this information, everyone. You should remember this information, please. If you think you have to write on your copy, you can write also in your copy. Do you want to write on your copy? Hello? If
Sir,
you,
can you explain it again one more time, sir? I didn't understand how you get that result.
yeah, look, we are given mass, right? We are
Hello?
given this mass 150 gram,
Yes,
and we are given specific latent heat 340,000 joule per kg.
yes, sir.
Okay, and
Yes,
you are asked to find the heat required to melt the ice cream. So
yes.
your formula is giving you the idea what you are going to find. Your formula is,
Yes, sir, latent heat.
yeah. Your formula is Q equals MLF, or you can write LF equals LFM. Right? Same thing,
Yes, sir.
because your capital L and Q are the same thing. What is latent heat? That
Yes,
is heat required. Till now you understood?
yes, sir.
Okay. Now the information given here, mass is given in gram, and your specific latent is given in joule per kg. So these two units are different,
Yes, yes,
isn't it? That's why
yes, sir.
you have to convert gram to kg. That
Okay,
will,
sir.
yeah, that will help you to get the unit and the numericals correctly. Otherwise, the numericals will come wrong. Okay,
Okay, sir. Yes,
is
sir.
it clear
Sir, can
now?
you tell what is the Q or
Q,
what is Q?
Q is the heat required.
Heat, what's the heat required?
Heat
And LF
required.
is,
What is heat required? That is your latent heat.
oh, okay, sir.
Sir, I have a
Latent heat.
confusion, sir.
Yes, sure, sure. Tell me.
Sir, here uh, I cannot understand, sir, the SI units.
Okay, SI
Like there
units
is a
you don't
problem.
understand. Okay, SI
No, no, no.
unit.
Like here the specific latent is joules per kg, but here it is just joules.
Kilojoules. This
Oh,
one.
yeah, kilojoule. Yes, sir.
Yeah,
No,
you
sir.
tell me where.
So here in the solution, sir, solution.
In the solution. Okay, solution you see, we have here 340,000. The unit is joule per kg, right?
Yes, sir.
It's joule per kg. So we are writing a joule per kg. Okay, for 340,000, and for 0.150, it is in kg. It is in kg, right? So this kg is multiplied with that joule per kg, right? So if you get this one multiplied, and this one is fraction, right? Kg is down and this kg is up. So we can cut them.
Oh,
Only joule is left. Now it is clear?
yes, sir.
Okay. So now we have some other students. Let us take feedback from them also. Adnan Rahim, you understood?
Brilliant student.
Adnan Rahim, you understood?
Sir,
You understood the discussion.
Sir, can you explain the division part of how the formula was?
Okay,
Like, sir, can
then
you explain the book's formula? So
Yes.
yeah,
what did it?
okay, I will explain, no problem. Then uh, Aisha, did you understand? You have anything? Hello, Aisha,
Yes, sir.
did you understand the discussion or you have anything to know more? We need to explain more.
No, it's okay, sir.
Is it okay or what they said we are repeating, no problem. And if you have anything also special, you can tell us. Then Rabi, Shafkat,
No, sir, all good.
all good. Okay, thank you. Now, look, the book's formula, Jawad was saying, right? Hello?
Yes, sir, Zawadus.
Yeah, look, the book's formula is the same thing, whatever we discussed here, same thing. Just rearranging, all the things we are just rearranging. If you look at this formula is coming here. As our question is asking us to find the heat required. Hmm. uh, to find the heat required. That's why we are going to find the latent heat. In Book's formula, they are saying that. Because
Oh,
heat required and latent heat is the same thing.
oh, okay, sir, understood.
And this one I wrote here. Latent heat of fusion and heat required is the same thing.
Oh, okay, sir.
Now the fractional thing, what Adnan Rahim told, that is joule per kg, right? Here the unit is joule per kg. If you write here, we are writing separately here, joule per kg. We are writing here. You know the fraction multiplication, right? And how they cut. Adnan. Hello, Adnan.
Yes, sir.
You know this one, right? How to cut. If we are getting joule per kg, that means it is 1 by kg. And it is
Yes.
kg. So we can cut this too, right? Kg
Yes,
can be
sir.
cut. And we have joules left. You are asking about this one, right? The fraction, how we cut.
Yes, sir.
Okay, now you understand how the
Yes,
joule
sir.
is coming. So any more
Yes, sir.
questions, anyone on this?
No, sir.
Okay, if you don't have any queries, then we can go forward, right? For the new things. You can solve this type of questions, right? If they are coming, they are asking heat required, you can write directly Q equals LFM, or you can write LFM, whatever you like, convenient for you, you can use that formula. Don't worry. Now, we are going with same thing. We have latent heat of vaporization. Latent heat of vaporization we got before, latent heat of fusion. Now latent heat of vaporization, only it is for boiling. Okay, so latent heat of vaporization, anyone can define from you? Anyone please?
Sir, I can. Sir,
Yes, please.
so latent heat of vaporization is the heat required to change to change a liquid to a vapor state or vice versa without change in temperature.
Yes, without changing any temperature. Like any example?
Sir, boiling water.
Yeah, when we are converting water to water vapor at 100 degrees Celsius, the heat required, that is called latent heat of vaporization. Is it clear?
Yes.
Like you are taking 10 kg water. So when we are taking 10 kg, the whole amount of water is converted to vapor that one is known as latent heat of vaporization. But if you are taking for 1 kg water, other than taking 10 kg or 15 kg, you are taking how much? 1 kg. That time it's called specific latent heat of vaporization. Is it clear? The same thing, the
Yes,
one we
sir.
did before. And for vaporization, we are just changing the symbol LV. Previously it was LF during the melting. Now it will be LV. Okay. And small LV. Okay. Is it clear now?
Yes.
Okay. So we can go forward. This one is similar. Now we will check out this question. This question worked example 7.5. The worked example 7.5. Can you please try it at home, all of you? Hello?
Yes, sir, sure.
It's in your book available. If you don't understand, then we'll repeat in next class. You try at home by yourself. Okay, worked example 7.5. This is your homework. Page number 161. Just record it on your copy. Record it. That page number 161. Worked example 7.5. It is your homework. Check out. Okay. The solution is also there. You just have a look on this and try to understand.
Page number
Page number
160,
161.
161. Okay.
Page number 161 and worked example 7.5. Then we are going to evaporation. Evaporation we will discuss later. Before that, we are going to discuss distinguishing properties of solids, liquids, and gases. The one we told. It's at the beginning. You see in Cambridge topics and your books unit, they are arranged oppositely. In Cambridge, these contents are coming later, but in your book, it's coming forward. Here is the 3 states of matter. Huh? These are very simple ideas. You know all these things you know before. They are talking about the structure of solid, liquids, and gases. And at the beginning, we are having the physical properties, the properties we can see from outside. That one is called qualitative properties, and this one we can understand from outside. Okay, so I want you to read it. Faiza, 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 can you please read this box, this table? State of matter, solid, you will say the properties, then liquid, you will say the properties, gas, you will say the properties. Okay, read.
State of matter, solid, properties, fixed shape and volume, normally hard and rigid, large force needed to change shape, high density and incompressible.
Yes, then
Then liquid, fixed volume but does not have a fixed shape, high density, not compressible. Gas, no fixed shape or volume, low density and compressible.
okay, is it clear, everyone? These are very simple things, right? So
Yes, sir, we
solid,
have
solid,
understood.
they have fixed shape and volume, and they are normally hard and rigid, and they need large force to change the shape, have high density, incompressible. So this part is clear, everyone? Hello? Very simple, right?
Yes, sir.
And liquid have, they have a fixed volume, but does not have a fixed shape, high density, and not compressible. Gas, they don't have any fixed shape and volume. They have lowest density, even, you know, less than liquid, solid. Then they are compressible. Gas can be compressible. And one thing I need to add here, these two, uh, they have another property, that is they can flow, right? Both liquid and gas, they can flow. Do you understand what does flow mean? Hello? Hello?
Yes, sir.
They can flow. Do you understand? Liquid and gas.
Yes, sir.
And that's why they both are known as what? They both are known as fluids. In your copy, you can also take these notes. They both can flow. That's why they both are called fluids. During convection, we discussed it, right? Can you remember? All of you. Hello? Hello? Can you remember this? We discussed during the convection that they can flow. That's why they both are known as fluids, liquids and gas. That's why uh, liquid and gas. Hello? Hello,
Yes,
students.
sir.
Liquid and gas, they both can flow. That's why they both are known as fluid. Is it? Is it clear?
Yes,
Everyone,
yes,
respond.
Yes, sir.
sir. Yes,
Yes.
sir.
Yes. Okay. So we are done with the physical properties. Now we have some other properties. Those are molecular level. You see, it's written here, the kinetic molecular model of matter. Okay. So here we have molecular structure of solid, liquids, and gases, and we have molecular movements of solid, liquids, and gases. So I want you, anyone, you will read it. Who is there? Adnan Rahim. Adnan. Hello, Adnan.
Yes, sir.
Yes, you will tell us this one. The first column you will read. Huh? For solid, liquid, and gases, we have the first column where we have arrangement of particles. That means molecular structure. So you please read this part. Can you see it?
Yes, sir, I can.
Yeah. Okay. Read.
Okay. Model of a solid. Arrangement of particles. They are closely packed together and occupy minimum space, usually in a regular pattern. This accounts for the high density of solids. Liquid
Yes.
occur in clusters with the molecules slightly further apart compared to that of a solid. This accounts for the high density of liquids and the tendency of liquids to form droplets.
Yes.
Gas very far apart in that the molecules will occupy any available space. This accounts for the low density of glass.
Gases. Low density
Yes, sir.
of
These are gases.
gases. Yes. So here we understand that molecular structure of solids in molecular level, how they are staying. They are tightly packed, right? Closely packed, and they are in regular pattern. And they have, that's why they have high density. And for liquids, they are staying in clusters and they are slightly further apart compared to that of a solid. Okay, and that's why they have less density than solid but more density than gases, and they have the tendency to become droplets. They are forming like drops. And finally, for gas, they are very far apart. Gas molecules are very far apart and these molecules have much more space, occupying lots of space. That's why they have lowest density. In gas molecules, they have lowest density. Okay, is it clear, everyone?
Yes, sir.
This one, molecular structure. And in our next class, we will have discussion of molecular movements. Okay, now we have only 2 minutes. You have any queries, you can ask me. Anyone have any questions? Anyone? Hello?
No, sir. No, sir.
If you don't have question, then just have a recap or summary what we did today. Yeah, Aziz Awad, can you sum up what we did today?
So the latent heat and the physical properties of the
Yeah,
gas. So,
anyone can add anything? Rabi is there, Rabi is not there. Then Shafkat, you can add
Yes,
anything
sir.
with Zawad?
We have done some numerical questions.
Mm-hmm.
One, then sir, physical properties of solids, liquids, and gas.
Mm-hmm. Okay, then
Then,
we also discussed the comparison between latent heat and specific latent heat, right?
oh,
And
yes, sir.
in the meantime, also we discussed when we went back for a while, we also had some discussions on heat capacity and specific heat capacity, right? All these things we revised today, is it?
yes, sir.
Okay. So thank you so much. We will discuss molecular movement from here next class. Allah Hafiz. Thank you so much.